Hello, everybody, and welcome to another episode of Moving into the Future. Today, I am joined by Molly Dee Ramasamy, who's the Director of Deep Carbon Reduction at JB&B Engineering. And today we are at the JB&B Engineering office, so this is quite special. It's Climate Week in New York. There's a lot going on.
Yep.
Quite a topical discussion. So Molly, thanks for joining us.
Thanks for having me. Looking forward to the discussion today.
Yeah, and we were just talking about it too. You know, the Director of Deep Carbon Reduction. I'm sure that wasn't a term that you heard very often 5 years ago, right?
It was not. In fact, shortly after we started our deep carbon reduction group and I started doing this job, people would routinely say to me, "What is deep carbon reduction?" And now it's all over the industry. It's caught on. It's definitely a thing. So, yeah.
Right. And see, that's the funny part of what you do, because you've been in the construction industry for over 10 years or so, but really you've had this role for the last 5 years. And within the last 5 years as a society, we've seen such a push for energy efficiency and carbon reduction. Since you've had a focus in the field, what has been the most profound change you've seen and as a professional and an expert?
That's a great question. I think in the last 5 years, the really big shift has been in the focus on carbon versus what we used to measure building performance by pretty consistently and still do in some ways, which is energy use intensity. So that's the amount of energy a building uses per square foot. And that was how it was for a long time, and that worked really well. People, were looking at their energy efficiency through that lens of EUI, and now there's been a big shift, and that shift is now specifically on carbon, right? And a building's contribution in terms of carbon emissions, greenhouse gas emissions, and the built environment in general.
Right, and we've already started to see it in New York City with some of the transitions and the new buildings that are coming up. I mean, some of the new buildings, and I know you guys are working on them, they're going to be really, really impressive with how energy efficient they are. And the LEED certification was always the measure of green success. But now with Local Law 97 and just more so the public awareness around energy efficiency and things of that nature, it's going to be really impressive what we see.
Yeah.
And when we talk about like EUI and carbon reduction and stuff like that, what was the standard before? I mean, everything was essentially running on oil and gas and that sort of thing, correct?
Yeah, so the big shift, in the new types of buildings that are being built now, specifically with this eye on decarbonization, they're largely electrified, right? And what we're talking about when we say electrification is we're talking about heating systems primarily, moving over from those fuels you mentioned before, natural gas, fuel oil, which was the standard for many, many years because those were less expensive fuel types, right? Natural gas is still less expensive than electricity. And so for a long time, that's what we were using for our heating systems. But now, as we're moving towards a decarbonized future, we don't want to be combusting those fossil fuels on site.
Right.
And so we want to transition those heating systems from natural gas and fuel oil over to clean electricity. And that's the key, right? And that's a really big shift in how the industry has really thought about heating systems, about energy and energy efficiency. Now it's not just about how little energy you're using or how well you're using energy, right? That would be your energy efficiency piece. It's also about how well you're recovering energy and how well you're using your equipment and systems to get off of those fossil fuel resources.
Exactly, and that's kind of how I understand it too. Is when you look at it like an office space as a whole. So we're in the JB&B office, and obviously I'm sure you guys are very efficient. But like back in the day, if there was nobody sitting in this conference room, the lights would still be on. Now we've gotten to a point. Largely, lighting systems are automatic, so they're based on movement. And if somebody comes into the room, the lights turn on. When they leave after 5 minutes, they'll turn off. That sort of thing. Right. Same goes for HVAC systems and heating and or cooling for that matter. If somebody's not in the office, it'll be kept at a very standard like 75 degrees or something like that, or maybe even higher. And then once people come in, even sections can be set at certain temperatures, based on the office and what people prefer. Is that more of the use of like clean energy, or energy efficiency, right? And,
Yeah.
and then therefore, so when you have to start cooling these systems or heating these systems with electricity over carbon, use, whether it's oil or gas or something like that, it can still, the necessary output to make it operational, even though that might be more, it's still reduced in other areas that allow for that to operate efficiently. Is that like correct in my assumption?
Yeah, so energy efficiency is the cornerstone of decarbonization. And so you start there, right? And you reduce your energy as much as you can through the things you mentioned, right? Lighting controls, high efficiency equipment. Other things that would count as energy efficiency would be set points and setbacks, right? You were saying, hey, if people aren't in the building, maybe we increase our set points so that we're not over cooling or overheating them or an empty space. So those are all energy efficiency items that are like the very first thing you have to do. And that reduces your load, right? And then when you have a reduced load, it's much easier to transition them off of something that's fossil fuel based,
Right.
like natural gas, to electricity. You can do it. You can go straight from what you have today right to electrified, but it's super expensive and it takes up a lot of space. And it just makes a lot more sense to start with that energy efficiency and that heat recovery first, get those loads down, and then you think about how to electrify. And that's the approach that new buildings are absolutely taking, right? They're pulling out all the stops on the energy efficiency, but then they're going those extra 2 steps to look at recovered energy, right? Why are we throwing the energy away? Once we used it, let's reuse it and reuse it and reuse it as much as we can.
How do they do that though? How do they reuse it? What does that mean?
Yeah, great question. So it's a little technical, but on the water side, right, within a building, maybe you have a water side system, let's call it a chiller plant, and that chiller is providing chilled water for cooling, right? Cooling is just extracting heat and moving it.
Right.
Now, historically, you would take that heat and you would throw it out of the building through the condenser water loop in the cooling towers. And if you go and you look at the rooftops, you can see in a lot of large buildings,
all over New
these
York.
cooling towers, you have, sometimes in the winter you can see the plumes, right?
Right.
The plumes are all of that energy, all that heat that's been extracted and is being thrown away. We're getting more and more innovative about recapturing and reusing that energy and using it for heating. Right? Why throw the heat away when you can redistribute it to a different part of the building that might need it? It's really obvious when you say it, when you're like, oh yeah, of course we would do that, right? But up until recently, that hasn't been the norm.
Exactly. And
Yeah.
that's part of this whole evolution that we're going through, right? Because again, we were talking about it before, where during the digital age and early on in the digital age and we around mass production, and even though that was in like the early 1900s, but a lot of that revolved around coal, oil, and gas. And the steam engine and transporting goods. I'm in that world, and I want to talk about that later in terms of transporting goods and trucking and just the amount of fossil fuels that we were using in order to sustain this new lifestyle of ours became just overabundant. And then we saw pretty much in the last 40 years, and more so analyzed in the last 20 years, really what we were doing to the environment, and just it's not sustainable.
Yep.
The way that we were doing things weren't sustainable. So now what we've done as we're really transitioning into this digital age, and this is why this conversation is topical, hence the name of the podcast, Moving into the Future. But as we're really taking that shift into the next digital age, we're looking for creative solutions to become more energy efficient. And that's just a simple example of one where we have the technology in order to analyze how buildings are functioning. And then from there, we can take that data and find ways to become more energy efficient. One of the things you mentioned too was cost. And I think that's when a lot of people are playing devil's advocate towards these things, they say, how much is this going to cost me? How much higher is my energy bill going to be month over month? When you're consulting clients on that sort of thing, how are you breaking it down for them so that it's easy for them to understand, A, they have to be at a certain level or else they're going to be penalized, but B, it doesn't need to be this way. Here's how we can make it where it's reasonably affordable or within a fair budget. Are you able to do that for clients?
Yeah, I mean, there's always sort of an upfront conversation that there is a premium, right, to go to a fully electrified building, it is more expensive. And the fact of the matter is that's because the cost of fossil fuel, natural gas, for example, doesn't include, the cost that would include all the externalities, negative externalities that fossil fuel has on society, right? It's just really cheap and kind of unfairly inexpensive, in fact. And so when you're comparing a natural gas system to an electrified system, there's going to be a price premium. But what you get in return, right, has a lot to do with health and wellness, has a lot to do with perception in the industry, right? ESG has been a really important movement in this last year or two. And people who are going to be going into buildings are asking building owners, what is your environmental outlook? What are your commitments? What are you doing for health and wellness within the building? And so this has really become pretty critical to having a set of real estate assets that's desirable to the market.
Right.
And so I think while there is a cost premium on the utility side, and likely will be for the foreseeable future, you get value out of making that change, especially because we're still in the point now where the people who are doing this on a large scale are early adopters.
Right,
They're
exactly.
really the first out
Exactly.
there, and they're able to say that kind of stuff like, we're the first fully electrified new commercial building. And that means something to people in the market.
It certainly does. And again, when you talk about that health and wellness aspect, that's a big part of it too. But one of the things I'm interested in too is the technology aspect of it all. And how are you studying those fully electrified buildings? And see, again, as early adapters, and when you're doing something new, like this is, again, the same thing for solar and wind. Like, it's expensive right now because it's a huge adjustment from the fossil fuel industry where things were done cheap. And I see why, that is. But when you implement technology that can then study the way these buildings operate, and whether it's through a building management system or some other energy-related software, I don't know. Are you implementing, or do you already use any type of technology that helps you study a building, whether you're going in for the first time and analyzing their energy output or carbon output, that you can then take the data from to create viable solutions in order to fix it?
Yeah, absolutely. That's a really good question. I have a couple different things I want to say about that. So in terms of how we evaluate buildings and how we study them and understand them, especially in the existing condition, not necessarily a new building, although we energy model, which I'll talk about for a second, in new buildings as well. In existing buildings, we can also build energy models, which are basically digital replicas of these buildings, and we can compare the real utility data to the utility data coming out of the model, which has all the systems and the geometry built into it, and we can calibrate, which means we could make that virtual building function almost exactly like that real building operates, right? And what that provides for us is a test bed to study solutions, as you say, different technologies, different ways of doing heat recovery, and to understand what that's going to mean for the building in terms of energy, carbon, and cost. We can take the outputs of that energy model and we could say, okay, it's going to equate to this much, energy savings per year, this much carbon reduction, and this many dollars in savings per year. So that is definitely sort of foundational to understanding what's going on. There's also a lot to say about the technology in terms of the solutions, right? You probably have heard a lot right now about air source heat pumps. Every time I feel like I open the New York Times, there's a new article about air source heat pumps and how they're great and how they've been around forever. And that's a perfect example of some of the exciting, I'll say new in quotes because heat pumps have been around for a long time, right? But they're having this resurgence and they are being reconfigured and sort of reworked in a way to fit the new market needs in places that are pretty tough, like New York, right? Where we have really cold weather and we don't have that much space. So there's new technology, climate tech in general is a real area of focus and investment right now. There's been this huge increase in investment in climate tech over the past couple of years. And to your kind of original question about energy management systems or building management systems, optimizations, there's plenty of prop tech or software-based optimization tools and softwares that we're seeing pop up on the market. In fact, there's so many of them sometimes it's hard to know as a building owner where to start. But I think you're touching on something that is really important, this intersection between cost and technology. And I want to take a second, just because it's so opportune, to kind of talk about this initiative that I'm involved in with a number of really influential real estate folks. We've got thought advisors and Rocky Mountain Institute and Institute of Market Transformation. We have some academic institutions that are participating. This initiative is called Benchmark 8760. And it is specifically about, looking at how buildings measure their performance and what the different data streams should be that go into determining it, because it's not just EUI anymore. That's kind of how things have been done in the past. But now we need to look at energy use intensity. We need to look at occupancy, to your point before, right? About, buildings not heating and cooling empty spaces. We need to look at grid intensity, right? So how much carbon is being produced by the electricity grid at any given point in time. And we need to look at weather, right? What are the weather conditions that are happening in a particular area that's driving the way that buildings operate? And so now we start seeing more of a need for data, more of a need for tools that actually capture that data and assess it in a way that, incentivizes building owners to do things a little bit differently than they have before. So I'll kind of leave that thought there, but I think you're getting at something really important, because if we don't manage that stuff, if we don't get smarter about how we build but also operate buildings, that's where the cost comes from.
Exactly.
Right?
Exactly.
Yes, that's where the cost comes from.
And that's where we can end up reducing costs, because the big concern is like affordability for, like poor people and stuff like that.
Absolutely,
that's where it comes down to. Those are the ones who are going to end up suffering, and like nobody wants that.
Right.
We're trying to fix these things. So that's why, benchmark 8760, you said it was?
Yep, yeah. Exactly. Benchmark 8760. We have a website. Anybody who's listening can check it out.
Yeah, that's really cool, because that's the type of initiatives that are really necessary in order to strive for cheap, clean energy is like the ultimate motive.
Yeah, exactly.
And you brought up something really important there, which is the weather. And again, obviously weather throughout the world is different in all parts of the world and stuff like that, but specific to New York, how is that going to affect everything? Because obviously the weather affects us. When it's hot, we want air conditioning. When it's cold, we want heat internally. But as far as the grid as a whole and the producing the energy, how is that going to work? Do you know about that at all? Are you? Can you explain that?
Yeah. So, it sounds like what you're asking is
with wind and solar.
Yeah.
Right.
So we're going to transition, all these sectors, not just buildings, but, in theory, transportation and waste, and all this stuff is going to go electrified. How do we make sure the grid can actually support all of that additional demand and load on the grid?
Right.
Yeah, it's a great question. And that's a question that people ask all the time. And it's a complicated sort of answer, but I'll try to do a quick overview here, which...
You say it, and I'll try to summarize it in a way that I understand it.
That's a good idea. So, I think from the generation component, right, the way that electricity is generated in New York, there's some really strong policy requirements and market signals that are being put in place that are encouraging power producers to produce power with renewable resources. And those renewable resources would be things like solar and wind and hydro and
And we're in a deregulated market, so we have various power producers that produce power for Con Edison.
Yeah, exactly. So here in this state, deregulated market, which means that power producers compete on the market to sell their electricity. And we have this organization, it's a nonprofit called the New York Independent System Operator that manages all that, right? And so all of that's happening on the generation side. The policy drivers are in place to move our energy production towards renewable. And that specific law, if anybody's interested, is called the Climate Leadership and Community Protection Act. There's a requirement for 70% renewable energy by 2030 and then 100% carbon-free electricity by 2040. So this isn't a huge time, delay we're talking about here. That's not so far in the future. And moves are very much being made now to reach those goals. So that's on the generation side. On the transmission and distribution side, actually getting the electricity to New York so that, Con Edison, our utility provider, does their thing. There's a lot happening there too. And that's where the concern tends to come from in terms of the support. Can the grid support all this electrification, right? Is there literally enough room, capacity, ways to get the energy here to actually satisfy that load? And, I think the short answer is that we on the demand side, meaning buildings, meaning electric vehicles, we need to be smart about how we electrify. That's our job, right? And that's the reduce, recycle, electrify. Get those loads down first. It's really, really important.
It has to happen on the commercial side first.
You mean like on the demand, like who's buying the power?
Like not in residential buildings first, right? Like, or is that going to be?
Well, they should too. I would say that, it's going to be a little harder for them in many ways because they don't have the same resources necessarily as large commercial buildings do to like take on all this stuff. But eventually everybody should be following this approach, right?
100%.
Reduce, recycle, electrify.
Yeah, but it's going to happen, I feel like, more on the commercial building side first.
Yeah,
that's going to be when you talk about reduce, recycle, electrify, it'll happen in those type of buildings first, or like we were talking about it before, that's where we're going to see the new buildings, coming up already have the standards set. And then we're going to go back and I'd imagine, again, we're going to start looking at the Class A buildings and making sure that all of them are, reducing their carbon footprint and then work down to the B, the D, the C, and again, those old pre-war buildings, those are going to be tough. And then when you look at like the multifamily buildings, that's going to be a huge undertaking. And like that is going to be last. And then, if you're looking at a residential like house, like let's say on Long Island or something, there it's a little different. And I want to get back to what we were saying. I cut you off there. But like with a residential house, people are putting solar on their roofs, which is great. Like, easy solution right there. But however, and I haven't done this, maybe Fred has, but it's a very hard process. So do you know anything about that too? Like, and I don't want to get cut off. Yeah. But do you know about like the process of getting solar on roof and stuff like that?
Well, I'm not super well versed in the details of actually getting solar.
I heard it's a real pain in the butt.
And connected.
Yeah, because you get a big tax break from that.
Yes, absolutely. And that, that we want to incentivize people to do that so that, that makes sense. But I have not put solar on my own roof because I'm in a historic district and I'm not allowed to. But I have procured renewable electricity because we're in that deregulated market and I can buy my power from whoever I want. So I, as a homeowner, opted to buying renewable electricity, and then I electrified my home.
Sweet.
So you can do it without the PV, although if you can get the solar voltaics up there, it's definitely better.
Yeah, for sure. And like obviously there's an upfront cost, but long term it's like widely beneficial.
Yeah.
But anyways, getting back to what we were saying before, there's the system operators and there is how they're electrifying these buildings through reuse, recycle, and electrify. Is that what you said?
Reduce, recycle, electrify.
Reduce, recycle, electrify. Res. And that's happening. And then what's going on from there?
Yeah, so that's the demand side, meaning we're the users of the energy, right? So our job is to be smart about how we electrify. And then on the other side, the supply side, the generation side, the utility side, I think to everybody's credit, you can see in the long-range plans from Con Edison and from other utilities that they're planning on investments to support this move towards renewable, right?
Right. There's a lot of money being invested, which is good. Again, we were talking about it.
Yep. There's a lot of money that's being invested, and I think what people have to realize though is that there, somebody does have to pay for it, right? These infrastructure upgrades are needed in addition to being for the renewable, sustainability, environmentally, beneficial side of things. We have a pretty old system in the U.S., right?
Time.
Like these investments in the
grid
are
railways
just needed.
Are insane.
Yeah, and so we are gonna bear the cost of that in the short term, but I think in the long term it'll certainly be worthwhile. But to kind of come back to this idea of, being smart on the building side on how you electrify, if we keep our loads down, right, then the grid operators and the utilities, they don't have to add more capacity necessarily, or they don't have to build out as much as they were planning, right? And so that's what's going to help us manage the costs. And I'm not sure that link is always so clear to people that, like, we have a role to play in the affordability of future energy and the way that we help to manage that is to use technology the way that we were talking about before, to be smart about electrification, right? And really to think about building performance in a new way, which is beyond energy use intensity and needs to have all those other things in it.
Right. Yeah, that's going to be really fascinating. And like considering how involved you are, because, you mentioned non-for-profits, obviously your role as director of deep carbon reduction and, you're involved in a lot of projects, ground up and stuff like that. Would you say the collaborative and collective vision as a whole is singular? Like, do people get it? For the most part, when you're bringing these presentations to the table. Obviously, there's always going to be pushback, and one of the worst part about this whole thing is it has become politicized, and for one reason or another. But however, I feel like for the most part, people have realized, specifically too from an infrastructure standpoint, like there needs to be some level of change and updating and stuff like that.
Yeah.
I don't know if it's possible to ever get away from like some level of carbon use, but with that said, the way that we're using energy can become much more efficient, and like and that's the big thing. You know, I think there's a lot of ways to do it. So do you think people generally understand that and grasp that?
Yeah, I think so. I think, at least in my experience, people want to do good, right?
Right.
They want to do the
They
right
wanna help,
thing
right,
for their
yeah.
occupants, for their business, for their families, right? For the communities in which they live. Truly, they do. And so, I don't get a lot of pushback on the idea that we should decarbonize and that we should be smart about it, right? And try to minimize the cost impacts and minimize the environmental impacts of preparing for that. Where the details and the questions and the decision making comes in is around the very specific implementation details, right? And we all know, especially in New York City real estate, existing conditions can be tough. You may have every intention and want to electrify an existing building, but it could just be really difficult with the existing conditions. There could be a lot of different circumstances that prevent you from getting all the way across the finish line. And so then I think our job, or my job as a solution provider and as a consultant, is to find the right solution that gets you close to where you want to be, still within the reasonable bounds of what you're able to do within those existing conditions. And so there's a lot of optimization and discussion and trying to figure out, okay, well, what is the most practical, most reasonable way to proceed, knowing that in a perfect world, we would all love, right, to be fully electrified, carbon-free. It'd be even better if it were cheap.
Yeah.
But because that's not the reality of things, we have to be smart about what we do and how we do it.
And see, like my grand vision is like, clean, cheap energy.
Yeah.
That's ideal. And I think we can do it. I think we're heading in the right direction. Again, I think with us being like fully integrated into the digital age, I've already said this, I think with that, it's going to allow us to make large strides moving forward. And it's going to be fascinating. And I know we're running out of time, but we didn't even get into trucking and like that aspect of carbon reduction and where that's going to go.
Yeah.
So we'll save that for next time.
That sounds good. That sounds
But
good.
I appreciate you coming on. Thanks so much, Molly. This was great. I'm looking forward to, obviously continuing to follow you and, seeing the great work you do. And thanks again for coming on.
Thanks for having me. This was great.
My pleasure. Thanks, everybody, for listening.
Yeah.
Talk soon.